Alright, welcome back. So we're going to be talking about impulse really briefly and then getting to the free response question for today, which is 2001 question 1. And just like last time, you'll have question 2 and 3 to finish on your own.
Mm-hmm.
Okay, so when we're talking about impulse, we can generally use Newton's second law and impulse momentum theorem to solve for what we're looking for. So Newton's second law says that our net force is going to be equal to our change in momentum over change in time. Since momentum is mass times velocity, your derivative of momentum would be mass times the derivative of velocity in terms of time, or mass times acceleration. So if I integrate the net force in terms of dt, then I would integrate the other side as well. If I integrate dp in terms of dt, I would get p. So I could say our momentum is the integral of our force in terms of time. Because our impulse is our change in momentum, we could set our force times our change in time equal to our change in momentum.
Mm-hmm.
Units for impulse are newtons by seconds. Units for momentum would be kilogram meters per second. Any questions on anything so far?
Nope.
Okay, let's jump right in. So we've got our motion sensor, and we're using it to record the motion of a cart along a track. The cart's given a push so that it moves towards the force center and then collides with it. The two sensors record the values shown below. First thing I want to do is determine the average acceleration between t equals 0.33 and t equals 0.37.
So that's just easy. Find the slope of the first graph.
Find the
Yeah.
slope of the first graph. Okay, so 0.33 is about here-ish.
Mm-hmm.
So I'm going to call that, we'll say 0.33 and 0.22,
Mm-hmm.
and then 0.37 here. 0.37 and negative 0.18, we'll say.
Mm-hmm.
Okay, so what do I have to do?
Find the slope. So 0.37. No, I mean minus 0.18 minus 0.22 divided by 0.37 minus 0.33. Then use calculator to find it.
Okay, I'm going to assume, I don't actually know if we had a calculator on this one, but if we don't, so what happens when I subtract?
Minus 0.4 and then divide by 0.04.
Come on, 0.04. Okay, so that gives me negative 10, and then what are my units?
Meter per second squared.
Meters per second squared. Okay, let's check. Use dt to get negative 0.4. Okay, from our graph, got 0.22 and 0.18 negative. Same thing we got. Okay, range of correct values. We actually got exactly what they listed with the minus sign. Okay, cool. So that was 6 points.
Yay.
Cool. Okay, so part B. Determine the magnitude of the change in the cart's momentum during the collision.
So that's asking the impulse, which is the area under the second curve. I believe. Yes.
Okay, so this is looking for impulse. Not looking at the right one. This is the one we just did. Okay, I'm looking for impulse. This is already force, so I am looking for the area underneath.
Mm-hmm.
There we go. If I'm looking for the area underneath, what would I have to do?
So I plan to cut 10. So make a triangle at the top and then trapezoid at the bottom. Yeah, like that.
Okay, cool. So what's my area of this part?
So that's 0.02 times, which is our base, times 30 divided by half. And then bottom part, that's 15 times that number, which is 30 divided by 100, so 0.3.
Okay. So they said 0.3 times what?
That's the answer.
Okay. I'm gonna reset this up then. So, what I'm doing in my head is this.
Oh, yeah, that's the same.
Okay, so I've got 10 by 0.03 is 0.3.
Mm-hmm.
Okay. So I've got two areas. Then I'll need to add them together.
Yes.
So this is half of my 0.02 is 0.01 times my 30. We'll move my decimal twice. So this is also 0.3.
Mm-hmm.
So I've got my magnitude of the change in the momentum. Change in momentum is equal to the integral of our force in terms of time. Our change in momentum was equal to A1 plus A2. Or 0.6. What are my units?
Impulse is kilogram times meter per second.
Okay. And we'll check. Okay. Found area using the second graph, 0.6 units. Okay. So 3 points. And determine the mass of the cart.
So the mass of the car is if we have impulse divided by velocity.
Okay. So you're saying our impulse is mv, mdv.
Mm-hmm.
So if my impulse is mdv, that means my mass is my change in momentum over my change in velocity.
Mm-hmm.
Okay, what was our change in momentum?
0.6.
0.6 was how much momentum we gained, so what was our change?
Um,
Okay,
0?
not 0.
I don't know.
Okay,
It's not 0.6?
so we've got our change in momentum. So we
Oh.
changed from 0 to 0.6. And then our change in velocity, we changed from a velocity of 0.22 to a velocity of 0.18 was a change of negative 0.4,
Mm-hmm.
we said. So negative 0.4. Okay, so what's my mass?
6 divided by 10 divided by 4 divided by 10, 40, 60, divisible 2?
3 over 2? Or in this case 1.5. What are my units?
Kilogram.
Kilograms. Okay, we'll check. Okay, statement on change of momentum, substitution, units. Okay, cool. And last part. I need the energy lost in the collision between the force sensor and the cart.
So we can do kinetic energy change.
Okay, so my change in kinetic energy is equal to what?
Have 1/2 m change in velocity squared.
Okay, you're right, but final minus initial?
Mm-hmm.
1/2 mv squared? That's final velocity, and 1/2 mvo squared. Okay, so I'm gonna rewrite that. 1/2 vf squared minus vo squared. Okay,
V final was at point 0.37, which is minus 0.18.
okay, we said our mass from the last one was 1.5. Okay, v final, we said negative 0.18.
Square minus 0.22 maybe.
Yeah,
And then we use calculator. This
okay,
time we should, I think.
okay, sure. Actually, this is physics. You've got a calculator on the whole thing, don't you?
Yeah.
Okay, I keep forgetting. So 1.5 divided by 2 times negative 0.18 squared minus 0.22 squared.
Mm-hmm.
That did not work, I don't think. Okay, let me try that again. So this is 0.18 squared minus 0.22 squared
Mm-hmm.
times 1.5 over 2. Okay, that's what I was expecting. I'm not sure what I did wrong the first time. Oh well. So my change in kinetic energy
Mm-hmm.
is 0.012. What are my units?
Joule.
Joules. Try to figure out what I did there before I move on. Oh, okay, this negative wasn't squared. That's why. Okay, cool. So let's check. We've got an energy statement using kinetic energy, 1/2 mv squared, and substitution units. Awesome. Any questions on anything from today?
Nope.
Cool. Well, thank you very much for coming, and I will have the free responses already in WeChat and Skype.
Mm-hmm.
I will try to post a course sites in the next 10 minutes or so.
Mm-hmm. And homework is on course side. Okay.
So we're doing questions 2-3 from 2001 this time.
For homework.
Yep.
Okay.
All right, thank you.
Bye bye.
Bye.